On that note,
On that
What
note,
a way.
we had this assignment where you were supposed to make a red cross and a bonus problem if you could make a sort of gradient based on a sine function, kind of a tricky technical thing to do. Who was able to make the red cross successfully?
I
Great.
got it.
Can somebody show their screen? Let me turn that on. And I just want to see which ways you came up with. Let me allow you to do this. Which way you came up to do this. Who would like to share? How about Andres?
Of course. Of course. Let me open it. Then I'll share my screen. So you guys seeing my max patch here?
Yeah.
Okay. Well, I had to do this bang here that says press to draw red cross because I could not get the load bang to work, which I would have if it just worked, but it doesn't.
Right.
And basically what I'm doing is what we did in class, which is just use an Uzi to send however many bangs there are for the horizontal and for the vertical axis. Then as it goes, it packs the number into a list so that I can assign a color, which is hard coded here on this message, which is the red 255. And for the other two, I put, actually I didn't do completely red. I did 255. Oh no, I'm sorry. This 255 is the other value, the alpha value. And then here are the three colors. So I have 200 for red, 5 and 5 for the other two. And then as I press it, it just assigns this into the matrix and it draws it. And then for the other one, let me open the other one here. Similar process, it's just that it goes through the sine function here as it, oops, I suppose this shouldn't have the horizontal line.
Yeah, that's right. We're not supposed to have a horizontal line. Did you name? Yeah, you named the matrices the same thing. So that matrix is still holding the old values.
That will not happen if I didn't have the other one open.
That's right. Yeah.
And then the sine function will just assign these three values back and forth because the resolution is just 5. So we're dividing the the first half of a sine function into 5 spots, which the first and last one are 0, and then this is the highest one.
That's right. Yeah. So you could do like a quarter of a sine wave to avoid going back to black, but that's the right idea. Okay, so that's good. Does anybody have any questions about this? This is the time for us to. If this isn't clear to you, then this is the time to make it clear.
I have a question. Sorry. I have a question about the sine function one.
Yeah.
So if I saw on mine, I did the same thing and I realized that the first and the last one were black.
Yes.
And I started at like, I think 40 just to give it a red. Does that still equal a sine function? Like, even though it kind of changes the gradient? Like it, I guess, kind of accomplished the same thing, but
yeah, I mean, it's what's the right answer here? The right answer is, does the color change according to some sine function? And what's the point of doing that, right? To show that we can generate numbers in many different ways to shade things.
I made mine fade up and down as a sine function. I didn't.
Okay.
I kind of thought. I guess I took it literally, but I also don't know if that's correct or not.
Yeah, it's basically correct. If you were able to use the sine function to determine a number that was then used to color a block, that is correct.
Okay.
That's the idea.
I have a question. It works for the RGB, but my alpha, whenever I tried to modulate that, it didn't do what I assumed it would do, which is just make it more opaque or more transparent.
That's right. So by default, right, changing the alpha in a matrix and sending it to the P window has no effect at all. So I think last time I showed that if you do jit.alpha blend and you blend with a black matrix, then you can use the alpha. And what the alpha does in the alpha blend object is it crossfades between the two matrices. So if we don't have another matrix to crossfade between, that's a thing. So we usually crossfade between a black matrix, or it could be a white matrix, or a totally different matrix.
Yeah, because it's not that there's a black background, it's that the values at each thing is literally black.
Right, exactly. So the alpha, using the alpha channel, which we don't see, is kind of tricky, and in different softwares it's kind of hidden what's going on under the hood. In this case, we would have to use some sort of alpha blend in order to make that do anything. So you're correct that changing the alpha value will have no visible result.
Sorry.
Go ahead.
I was wondering, this is like off topic, but I was just trying to ask before we move on. What was the deal with the load bang thing? Like, why were...
Oh, I solved that.
Okay, what was wrong? Because I didn't have any issues.
You didn't have any issues at all?
I just used load mess instead of load bang, and that worked. And I didn't know if anybody what the difference was between the load bang and the load mess would be in that context. So when everybody said that there was a problem with load bang, I wondered what the issue was, because I just used. I'm just curious as to what the issue was, because I didn't feel like I knew what was happening when y'all were talking about that.
The issue is that the jit.p window that we create in the patch takes a while to instantiate. And so if we send it a matrix before it's ready, it doesn't work quite right. And so the solution that Ryan came up with was to defer the bang in the scheduler. What does that mean? That means that, remember that we have different things that take different amounts of time, and we can put something with defer load to the back of the least important queue. So you go to the back of the line, and it's actually the line to get into the line. and so he was able to accomplish this by saying, well, the bang is just, we're banging out the matrix too early to the P window. It's not ready. How long should I delay it, right? So then you're tempted to put in like a delay of 10 milliseconds or something like that. But we just don't know how long it's going to take for the P window to do its thing. But it should actually be I think, probably in the queue somewhere. And so if you use defer low, I wouldn't be surprised if it worked.
I used a metronome, so I think that is what stopped that from happening with me.
Yeah, if you use a Q metro and it's always banging the matrix, then the P window will be ready eventually, and you'll bang the matrix through at some point. So that's another solution to that problem. But if you wanted to be super exact, so Andrew brought this to my attention. He's like, and we narrowed it down to like, it just doesn't work to send a load bang to a matrix to a P window upon opening the patch. And then we tried different scenarios where it would work in some cases and not. So it's not a huge deal. But it would be a nice thing to have work correctly if you want it to. So it's just a kind of a very minute detail. All right, so today I wanted to talk about, now that we've done that, there's a few things I actually want to talk about, but I think it's best that if we stick to, we'll just see how it goes. I have too many things on the plate for today, so I'll try not to overwhelm. Let me pull up what I'm supposed to pull up here. This is very interesting. And oh my gosh. Having an office computer has its ups and downs, because I work on a laptop at home. All right, so let me share this very simple thing we're doing here. All right, so here's a few different things, and let me start one by one here. Okay, so just to show you, you guys can see my screen, right? So here's the red cross, right? Done my way, and depending on how we size this window, that red cross is going to look better or worse. So here you see I use the same sort of thing Andres was doing. Here I have an 11 by 11 matrix for fun. And we see that we're setting the cells along the horizontal, and we're setting the cells along the vertical to be certain things. And this is a brute force sort of way of doing things. We're just one by one setting cells. Kind of an unusual pursuit. So I have an 11 by 11 matrix, and it shows the red cross like this. So we can do things with this, like maybe we could add values to this. Maybe maybe there's a way to make this whole red and black actually less bright. So let's look at how we might do that. And this is part of what you'll do for your study this week, is to look at math operations on matrices. So there are different things here, like jit.op, where op stands for, let me blow this up a little more. Op stands for operator. Right, so there's many different operators, plus, minus, multiply, divide, and lots more. So we can say jit.op at op, which one do we want? And actually, that plus sign can be done. In this case, we have 3 matrices. So for each one, I can have its own operator. Right. So jit.op on the first plane, the second plane, and the third plane do all pluses. Right. So in this case, maybe I just want to change the red amount for each of for every cell. There we go. So I'll say pass. So don't do anything to the G and the B, the green and the blue. And then the second part of this object that matters is called value. What would we like to add to it? So it can be a single value, right? You could also add a whole other matrix to this if we wanted to. So here I'll add the value, what do we do? The character matrix. So actually I think I want to subtract. I'll subtract a value 100. All right, and then I run this matrix to here, and I will just make a new P window here. And there it is. You see that it's darker than that one, right? So we were able to perform this sort of operation on the whole plane of data. So this is operating not just on the red cross bit, but also on the black. But if I subtract, 100 from 0, it's basically still going to give me 0. So this is kind of a dimming function, if you want to think of it that way.
Could you have minus plus plus, and so it would subtract from the first value and add to the second 2 values?
Let's find out what happens. There we go. But we see it added to the black, right?
Can you set limits or ranges?
Because
like if this goes above 255, it would be kind of weird, right?
Well, I think it would just kind of clip at 255. I don't know the answer to your question, I suppose. Okay, so that's kind of simple math operations, and that can be useful if we want to multiply 2 things together. We can get some interesting results. So for instance, if I took a video of some chickens and I said, all right, well, I'm going to multiply on all planes this chicken thing, and I'm not sure what's going to happen here because this is a 4-plane matrix. So we'll find out. And I'm going to multiply that with no value here now. So I'm just going to multiply 2 matrices together. So what's going to happen, right? Well, anywhere we have a 0 here in the black, obviously 0 times anything is 0. So the chickens will not appear there. And we also have 0 in the planes for green and blue here. So really what we should get is anything red in the chickens video that happens. I mean, it's really just going to be a few pixels. This is 11 by 11. This is a pretty weird thing to do. But we should see some combination of those 2 things. So let's see what happens here. No guarantees that anything cogent will happen. There you have it. Nothing good. Well, we still get this, but it appears that the chickens movie does not cooperate very well because this is 4-plane matrix, so it really doesn't make much sense to do this. Anyway, I'm going to skip that for a second. That kind of a failed demonstration. All right, so below here I have something that I'm going to get to in a second. But over here I wanted to show you that because we understand now about the planes that represent colors and all that, I wanted to show that there's this plane map option. Like, how would you like this matrix to switch around the planes? So here I said, oh, well, make the green plane the red plane, make the red plane the green plane, and keep the blue plane the blue plane. So now this same thing, which I filled all these values for red with 255, now green is filled with 255. So that's this little plane map. And it's kind of fun to mess around with stuff like that. So for instance, let's bring back the chickens, and hopefully they'll cooperate a little more this time. So here's our chickens, and I will have this matrix adapt to whatever the chickens matrix is. And here we have an alpha channel, so I'm going to say that 0 stays at 0, and now the red becomes the green becomes the red, and the blue stays the blue. Hopefully that makes sense. And we'll see what the chickens look like. Yeah, so everything red there turned green. Hulk chicken. Okay.
That's cool.
Yeah, so these are the sort of things we can do. Now another way to do that is now, so we're just talking about planes, right? I'm trying to keep this to just the planes of data. So the alpha, the red, the green, and the blue. And just to remind ourselves of that, let's look at the jit.cell block. And let's look at what's here. And let's get all of the numbers showing. Column width. There we go. So here we see, to remind ourselves, to review, the alpha, the red, the green, the blue. For every pixel in this video, which this is a lot of pixels. I think this is a 1080 video. So there's 1920 across and 1080 down, as opposed to our 11 by 11, right? There's a lot of numbers to look at here. But these are the planes that we can manipulate, right? So it takes all of these, every cell that has this alpha, red, green, right? Every green cell we can affect using these plane operations. So another way to do what we just did is jit.unpack, which has a corresponding jit.pack. So here we'll say, well, there's actually 4 planes to unpack. So I run the chickens into here. Scoot over a little bit here, running out of room. Just get rid of this. There we go. So I unpack these things, and then the corresponding is the jit.pack. So what's this going to do? This is going to take all the planes of data and separate them out. So here's our alpha. We'll put the red to the green to the red, and the blue to the blue. This last one doesn't do that stuff. It's just for seeing other messages. So now I've packed up this jit.pack. You see that it's now repacked into a matrix that has the plane swapped. It's doing the exact same thing that this is doing. And we can view the result here. And we see it's the same. And here we can have a little fun and say, well, let's see what happens if I make the blue the red and all this stuff. Right, so now I have this going on, or I can do some weird stuff like that.
Kind of trippy.
It looks great. Okay, so that's jit.pack, jit unpack, also similar to the plane map. It's basically doing the same thing, right? So this idea of working with color planes in video is important for you to kind of understand. This is what's happening. It's pretty broad-based, though. We're talking about colors of all the different cells. So here we're not really changing individual cells so much. We're having to kind of work globally with colors. All right, so remember the jit.unpack and the jit.pack. They can be quite useful. And you know what's coming out of each of these things? Well, what's coming out of each of these things is a matrix, right? So it's actually just a single plane matrix. So if we were to do something weird like just run this to here, let's see what happens. Right, we get black and white because now it's a one-plane matrix. And we can see the green channel or the blue channel in black and white. Which also means that we can perform these matrix operations. And here I'll show you a different way to do it. So I just want to, it's a one-plane matrix. I don't really need to be too specific. So the jit.op things actually all have sort of corresponding jit.whatever. Just multiply.
Dr. Thompson?
Yes.
Is that window that the video's playing in, is that a jit.p window or is that a...
Yes.
Okay, so if when people do performances with this stuff, do they use a jit.p window or what do they do?
No.
Okay, so
It's a jit.video plane and there's a jit.window. There's a...
Well, what we're doing right now, like, is we're simplifying still. So if you wanted to just make it so that it's in a free-floating window, you just use jit.window. So there it is. And then if you look at the help file, there's ways to make this full screen.
okay.
In the end, for technical reasons, this probably won't be the way that you would end up doing it because we're working here all on the central processing unit as opposed to the graphics processing unit. And as the class goes on, we'll learn how to move things to the GPU to be more computationally efficient. But for now, I'm just going to leave it like this, and we're actually just going to work with P window because it doesn't float around, and we can have a lot of them on the screen, and it's fine. Okay, so here I want to say I'm going to multiply one of these channels by some amount, and it looks like I should be able to pass a message like val $1. So I'll be able to adjust this in real time. So any attribute here can be used with a message that says the same word followed by some number. So in this case, this is the same as what I just did. I can put the $1 there to take an argument for some changing number and then see what happens if we do this. Okay, so I'm going to run the red channel into this multiplier. And the alpha to the alpha, and the green to the green, and the blue to the blue. And then we'll look at the chickens here in this P window, and we can add in our red or subtract our red. And if we wanted to, we could make some function that changes that dynamically, or you know, we could use sound to change this number.
What do you put in the second inlet?
Here?
Yeah.
Remember that these, let me write another one up here. Remember that these operations can operate with a fixed value, like 0.1, or it could be another matrix entirely. So if I wanted to multiply by a whole other matrix, right, then I could do that. So matrix 2. But here I don't really want to do that. I'm just using a scalar value, as it's called, 0.1. And I'm just scaling the red plane in this case. And you know, there's a ton of operators. A good way to figure that out is use the jit.op. And then if you click on the little thing here and you get the attributes, let's see. I'm missing, I guess I'm going to, oh, there it is, op. Then you can take a look at all of the different types of operations you can do. So multiply, divide, add, subtract. Minimum, maximum, average, absolute value, all these things. And they're fun to play with. You know, you just run some videos through these operations and see what they do. There's our friendly sine and cosine operations. This would put the sine function on every value coming in. Anyway, it's a good one to play with, to do just simple math operations on the numbers that we see as video. All right. So we had this plane map, that was a thing. And we showed different ways to kind of accomplish that in more flexible ways. Cool. So now I want to go over here to this object called rota, because we've talked about changing colors, but we haven't really talked a lot about how would I change which cell has the color, right? And so if I think about how would I rotate this so that it spins around? Well, doing it this way with the set cell thing seems pretty hard. You could do it, but you would have to sort of figure out like, okay, well, this one goes in a straight line, so this next one's going to have to kind of go like this. It seems really hard. But in math, in linear algebra in particular, there is the idea of matrix math. And so in the math of that, matrices know how to rotate. We don't have to know that math. We can use objects that have that math already written out in them. And one of those objects is the jit.rota, like rotate. And it does more than just rotate. It can also offset these so they move to the right or to the left or up or down. We can zoom in or out, things like that. So here I've set the anchor of the rotation to be in the center. So if I don't anchor the rotation in the center, it'll rotate as here is the anchor point. So it's kind of rotating around this top left corner, which is not what I want. I want it to rotate around the middle. So we've got this anchor X and anchor Y. So anchor X being 5 means put it here. Anchor Y means put it here. Remember, this is an 11 by 11 matrix. And then we have this thing called theta. So theta is a Greek letter usually associated with a rotation value. And here again, it is in radians, not degrees. So as we said before with the sine function, radians, to go all the way around a circle, we go from 0 to 2 pi, which I'm fudging 2 pi here. So it'll spin from 0 to 6.28, that angle. We will spin this whole thing around. And then when the line's done, I bump it back to 0 because 6.28 isn't exactly all the way around. So I made a little compensation for that. So let's watch what it does over 5 seconds to spin this thing around. There's the second, the third, and the fourth. We're all the way back around and then pop to 0. So you can imagine in your mind maybe what those numbers are doing and the difficulty of maybe achieving that if you don't know matrix math. So let's look at the jit.cell block. Plane -1. And let's take this again and expand it out slightly. So here we can see our cross, right? Left to right, and we'll look at all of them. Actually, let's just look at the red. That makes the most sense. Okay, so here's the red. And as I rotate, we'll see those numbers sort of rotate around like you might expect. So that's what it's doing. Additionally, we can use this offset X or offset Y to move things from left to right. So at first, I'm going to keep the bound mode at 1. So we'll see this. So I'm going to move from -11. So if I shift all of this 11 over, there would be nothing on the screen. And then slowly it'll move all the way to the other side where there's nothing on this side of the screen. Let me just show you what that looks like. So there it goes. There goes our cross. It's moving across the thing. And then I bumped it back to 0 at the end. So sort of simple ways to reposition cells, kind of move, translate, or rotate cells around. If I don't use the bound mode 1, so let's choose a different bound mode here. And again, notice that this attribute, let me do it this way. This attribute at bound mode 1, remember I can just make a message and I can change this. So I'm going to switch it back to bound mode 0. So this means what happens if we go off the screen with our pixels. So let's see what happens with our rotation with a bound mode of 0. And we see that this line just kind of remains. So it doesn't disappear, it kind of it's retained there. And that's just the way it's wrapping the pixels around. So in this case, what really kind of makes the most sense is the bound mode of 1, which will clip these off if they go off the screen. And we could do offset Y instead and see how that looks. Right, as you might expect, it looks like that. There's also a zoom, and I haven't tried this here, but let me grab it this way. So attributes, zoom in on the X, let's say. And here the bound mode matters again. So I'm going to zoom in slightly, and then we're zooming on the X, right? So we kind of make this one bigger, or we can make it smaller. And depending on our bound mode, that could have an effect. In this case, not so much. Interesting. Okay, so that's this particular object called jit.rota. And the reason I bring that one up is because we look now, instead of changing colors, changing cell values positionally, I suppose. And I use this jit.rota object a lot. It's very useful. Okay, so what I want to do now is we talked in the class about Scriabin's color organ. And let me look here for a second. Whoops. So I'm just going to take this to a new window here. So I'm going to make a collection. And so for those of you that don't know, a collection is something that holds text, looks like this, and it's got an index 0 that will recall these three numbers. So 25500, which is the color red. So if I pass this col object a 0, it will return out of this outlet here these three numbers. If I pass it a 1, it'll return these three numbers. And I'm going to make sure that it doesn't disappear on me by embedding it in my patch. There we go. So these are all the numbers of Scriabin's color organ. So for each of the 12 notes in the chromatic scale, we have a color. And to just sort of look at that, so for C sharp, that's the color. For D, that's the color. And so to visualize that, right, three-plane character matrix, let's make this 12 by 1. So we'll have 12 columns going across. And the idea, well, let's just have one for now. We'll just have a P window sort of matrix. So here I have a three-plane, one-dimensional matrix, so just one cell. And we'll just look at the colors for now. So let's do this. I don't think I can do that actually. So I'll use a Q metro to constantly bang out this matrix. And then we'll call up a color. So there's what E flat looks like according to Scriabin. And we'll look at G flat or F sharp. There it is. And here's what B is. That color blue. which is different than B flat, which is gray. Okay, so the goal here is let's build a color organ. So we're close, right? We've got all the colors. We can call them by name, but it would be cooler if I could, you know, play a keyboard or something and get these numbers. So I'm going to use
K-slider.
Could use K-slider. Let's do that. K-slider. K-slider. So this gives me a keyboard slider, and to keep it simple at first, we'll just use this for now. So here's the velocity, a MIDI velocity from the K-slider, somewhere between 0 and 127. And here is our note. So that gives us some value. Let's look at what those are. I will pack them up, sort of like jick.pack, but the max version.
Wouldn't you have to modulo or something?
Yes. So here's the pack. And if we look at the values coming out of here, then right here we have middle C played with a velocity of 14. Okay, well, I'm just going to ignore the fact that there are note offs in the world. I don't think this one provides us any note offs, so that's great for now. Obviously, we don't have in this collection any index that is 60. There's just 0 through 12. So in order to turn this note into a value that collection will understand, we have to recognize that the notes basically wrap around at 12. So if this is 0, then by the time we get to B, we're at 11, and then we're back to 0 again. So 12 becomes 0, and it just loops like that. That operation of limiting how high a number can go and wrapping it back around into another set of numbers is called modulo, and it looks like this. So that's the modulo sign. So if I were to put the number 12 in here and say wrap around, 12 becomes 0 if we give it the number 12, then I can give it the number 11, and just like set theory should do, this should be 11. And if I give it 12, then we would expect this to give us 0, which is C, right? And then C sharp is 13, just like C sharp is 1. So here's our way of kind of dealing with octave differentiation. Or not actually throwing out octaves, just forgetting that they exist. So here is our thing. We're going to take this modulo and look at the notes coming in and decide which pitch class they are to talk music a little bit. So now we're talking about the pitch class. C is any of the C's on our keyboard here. And then we can talk to this collection with it, and we can play our keyboard and get the correct note. All right. That's cool, but I can't really play a chord, so that's not so cool. So what I'd like to do with our time here is to walk through how it is that I would have a 12 by 1 matrix so that each column here, so let me do set cell 0, 0, the first column, val 255, 0, 0. So we would expect this to light up, whoops, we would expect this to light up the first column. So there we go. And then if I wanted to set the second column, I would move on the x-axis, so to the right, and then I could set the next one to some value. But I don't want to do that this way. What I want to do is I want to use the collection so that when I play a note, it lights up the appropriate column associated with that note and turns it the color that Scriabin says is appropriate. Right? So from left to right, we have C to B, And as I play any note, it should light up the correct column, and it should make it the correct color. So how do I do that? There's a couple things that have to happen, right? We have to have this set cell message. This number here needs to be known. And then these three numbers here need to be known. So I put in these little dollar signs, which means I don't know what it is now. I will tell you later. And because I put 1, 2, 3, and 4, it means it's expecting a list like this, right? So we could say the third column with values of 10, 128, and 10. If I send this to this set cell message, then we get that color there in the appropriate column. All right, so that's almost correct, right, for a very basic part of this. We just need to get these values correctly sequenced.
Would you pack the modulo and the output from col into like a list and then plug that in?
Very good. So let's pack together. So we're trying to make a list, so we use this pack object, and our list has to be 1, 2, 3, 4 big. They're all integers, so I'll just put in i's there for integer. So 4 things. All the things out of here, and then all the things out of here. So because I don't really like pack for this, I'd prefer join. I'm just going to use that, ZL join. So this will join together 2 lists. So this is already a list. So I say, well, I know that's got to go there. So there's 2, 3, and 4. And then this is supposed to go here.
Can you export the index from the collection?
Yes. So right here is the index from the collection. The
And
number
that
or
would be
symbol
effectively
associated.
the same, right?
Be the same. And in this case, it's actually the same problem, right? That what's going to happen here? What's our issue? So this happens first, it outputs the list, and then this tells us what the second part of the list is. Again, classically, we have an order of operations problem. And the question is, what do we do about it, right?
Do you just switch them? Because aren't you storing the list first?
I could switch them. So I could say, all right, I'm going to put the list here, because that happens second, because we do right to left operations, right? So this comes out first, then this comes out second. So I can say, well, first, I'll put that there. That's the index now, and now this is the list. And so now we have, we would have to change our list here, like our, so now what is, this is now 1, 2, 3, and this is 4. Or we could just conquer the order of operations problem and say, well, really what has to happen is we have to control when this number does what. Okay, so first it's going to give me a 0, right? And we have to decide what we want to do with that number. So let's get our, I don't know what I did with this, ZL join. And we want to first be able to set the collection. So first we'll do this. All right. And, like I've said for a while, this is the hardest thing in Max is dealing with order of operation. And the best way to do it is just slow way down and think about the order in which you want things to happen. And then the next thing we want to do is take that index and say, all right, now output the list. So here's our red inlet that shows that this will actually output something. This is our blue inlet that says I will not output, I will just store these values. And now our list will consist of the index followed by these 3 numbers. We can put that into the set cell. I can't even tell where that's going. What in the world? Okay, that into the set cell, and then we need our matrix object. There we go, and we'll just always bang that matrix object through. And ideally now, when we play a note, it ends up in the right place with the right color. Great. There's a problem, though, that if I were playing this on a keyboard, I would only be able to play the 12 tones one time, and then my matrix is complete. So somehow we need a way to set these to black if it's a note off.
Would
So let me
clearing
change.
it do the same thing?
Say it again.
Could you clear the things, or like clear the matrix, kind of like the?
I could.
Or yeah.
But what if I play a chord and I let go of one note? I don't really want to clear the matrix. I want to hold on to those other two notes. So I need to set specifically a column associated with the note off.
Can you have like a note? Can you have like a note off message trigger, like a set this line to black?
Yeah, velocity 0 or whatever.
Yeah.
Can you strip note it and then just take that value,
Yeah, exactly.
the hanging value?
Well, so strip note, so what it does is it gets rid of note off messages. And it gives us the pitch and the velocity.
Whoops.
So we lose our note off message, and we actually need it. So this is kind of a little tricky problem, and I do it every time I teach this. And it's funny because I struggle a little bit, you know, just to kind of get the logic of it down, and then I do it, and then I look at last year, and I'm like, oh, I've already done this, and I actually do it the same way every time, which is pretty amazing. So what we need to do, right, is actually write an if statement. So kind of a computer programmy sort of thing, but we need to say, you know, if what's coming in here, so here I'll say if $I2, that's going to be my velocity. So an integer, the second one in this list. If that is, let me just go here to the one I've already done. So if the velocity is greater than 0, then that means it's a note on message. So just output the note. So remember, we're looking at these things here. This is what it looks like. So the note followed by the velocity. If that velocity is greater than 0, then that means it's note on. Otherwise, if it's not greater than 0, then go out the second outlet and still give me the note. So I'm getting the note in either case, but it's coming out either this outlet or this outlet. So if it's note on, we already know what to do here. We say, all right, if it's note on, do this. And let's clear this matrix out. What did I do wrong here? Oh, so I didn't pack it up. Yeah, so if the velocity is greater than 0, then do what we normally did. And then if it's, let me clean this up a little bit. Then if it's not greater than 0, we need to do something a little different. And there's a couple different ways to approach this problem. I'm going to take the easy route here and just make a 12th one. So you see that this is black, 0, 0, 0. So this is the 13th one, actually. So we'll have a 13th thing here. So if it's note off, I actually want to call the 13th thing here from the collection. So trigger this is the note, right? So we still need to modulo 12 this thing. So when you get the note off, tell me what the note is. We know it's a note off, so we'll call number 12 to the collection. And this may seem a little confusing, but just bear with me. So there we call number 12 to the collection. I mean, maybe we should just make our own ZL join here. Just keep it clean. So call those. Can I name this collection? Hopefully it doesn't make it go away. It does. I approached this a different way, but I'm doing it in a way I think is as clear as it can be. All right, we'll take just the same collection. So if we look here, it's still got all those numbers in it. And here, if it's a note off, we will get the 12th index of that, which gives us 0, 0, 0, a black color. And we'll put that in the right side of the join. And then we'll say which column is supposed to turn black is this number here. And then we can use this set cell to do our thing. So let's make this, I'm just going to turn this into a MIDI note in. Because I have a keyboard right beside me here. So here's the pitch and velocity, and make these look the same, I think. So there we go. Okay, and we'll look down here at our right. It's pretty hard to play this far away. So let's play a chord and see what it looks like. Oh, nice. Let's play some just all black notes. You could tell Scriabin's a piano player because all the black notes look really great. And then if you just play the white notes, it's kind of lame, my opinion. All right, so there's a thing, and I challenge you to recreate this on your own. It's kind of a fun little exercise to create Scriabin's color organ. I guess if you wanted to go whole hog, you could figure out what happens when we have a well, you could make different rows for the octaves, for instance, or what happens if we hold down the sustain pedal or whatnot. Okay, so that was
a pitch bend. What happens if you have a pitch bend?
Oh, yeah, exactly. Good question. All right.
Sorry, I have a question. Can you interpolate between the values in the call, or is it pretty like set? So like, kind of going onto the pitch bend thing, like if you had a pitch bend, could you interpolate between those first and second index?
Yes.
Cool.
Yeah.
Sweet.
Oh, no pitch bend. It's not allowed.
Scriabin didn't have pitch bend.
Sad.
Okay.
But he did have 432 as the tuning.
Did he really?
I have no idea. It's just, I'm just memeing about.
He's just trying to align it. Jared's trying to align his chakras.
Yeah, I'm trying to align to the frequency of the universe.
Yeah.
Good luck.
Godspeed.
It's not working right now.
I think the truth is that the frequency of the universe wouldn't have is infinitely resolved, as I like to say. So you would always get closer and closer, but never quite there. It's kind of like all the numbers of pi, right? Okay, so last, that thing we have to get to here is the jit.record object. So we did some fun things where we say, okay, wouldn't it be cool to, play Scriabin's color organ? How do I actually make movies? How do I make my own abstract film using these basic techniques that we're using, right? So this could be anything. It could have been my rotating, Atari 8-bit 11 by 11 pixel of a red cross. It could be the Scriabin color organ. Maybe I want to record it. And so this jit.record object requires that you say how big is the recording. So here I just have 320 by 240. It's a pretty low res movie. And it takes different messages, but here's an easy way to do it. So we're going to open up a file for writing. It'll be written 30 frames per second in the H.264 video codec. So if you don't know what any of that means, these are decent settings, and just copy and paste it. So when I hit write here, it's going to say, where would you like to save this movie? And I will save it here. Call it today. And so now it's ready for me to start recording. I don't have to hurry necessarily, but I am right now sending out matrices at 33 frames per second. So I'm recording a lot of black window. Let me play some things. Okay, and then I'll hit stop. And I will go and find my movie somewhere. Today. So there's all the black window, and eventually I play my, there we go, play some stuff. Right, and it's in time. It's in time because I have this Q Metro banging the matrix out. However, if I wanted to do frame by frame, I could just send the matrix to the record and it record 1 frame. So I'd have to send 30 frames for it to equal 1 second. So here's how we kind of can do stop motion a little bit. And the assignment I have for you is kind of wildly free. All I'm asking you to do is use this jit.record. You can make it 320 by 240, but you may want to make it a little bit higher resolution than that. I want you to use this jit.record to make a movie, like a short abstract film, right? It doesn't have to be your magnum opus by any means. And, feel free to look around and decide what might be interesting. You don't have to stick with what we've talked about in class. So for instance, you might be interested in jit.bfg, which is a basis function generator. You might choose to explore that. Or you might be interested in manipulating movies like this. Or you might be interested in, some frame by frame matrix manipulation, which would be interesting. There's lots of different things to do here. And what I want it to be is just an avenue for you to play a little bit with these ideas and these objects, because that's how you'll actually figure stuff out, is trying to get creative with it and making that happen. So right now we're not dealing with sound at all. We're still in the 1920s kind of aspect of this, where we're just going to make films that are pictures in time. These are a little exercise, so you can go whole hog, but I'm not expecting you to do much more than accomplish the task.
If you wanted to add sound, would you have to do it through MSP? Like do a separate section?
Yeah, it would be really difficult, right? Because in this case we have something that is frame by frame, and so we have no guarantees that that'll sync up with sound. Syncing up with sound, I would actually do this a different way, but for now we're doing it this way as sort of a different idea. So no sound for now. The way to do it with sound is you would use a jit.siphon server in all likelihood and record in real time, using your graphics card. We'll get there. Okay, so there's that. That's what I want you to be able to kind of work up to review. We had this cross thing that you were to do, which deals with the setting of the cell. And now we're starting to see that there's actually a lot of objects that deal with, once you have a matrix of stuff, you can transform it in various ways. It's kind of the equivalent of effects on a sound, right? rotate the image, zoom into the image, whatnot. And then we looked at, how do we map planes around? We can do that. We can do it with the jit.unpack and the jit.pack. So we can kind of change things around. We can do math on matrices, which is part of your study, which is to look at the math on matrices, or math on a matrix, as they call it, Jitter tutorial number 3. And to look at Jitter tutorial number 1, which is play back a QuickTime movie, which should be really simple. And then lastly, we kind of looked at the Scriabin color organ, which kind of puts together a lot of different ideas, right? There's a lot of, if you weren't in the class last semester, then a lot of this may seem like, wow, that was a lot. If you were in the class last semester, then this seems like, okay, yeah, I understand that. It's hurting my brain to review it a little bit. But ways that we can use this set cell idea simply. And then lastly, the record. Okay, so I want to show you one more thing that I'm going to leave on the Folio site for you to investigate on your own. And this is, I wanted to whip some stuff up here that shows different ways of filling a matrix. You don't always have to use set cell in such a tedious way, right? So here is the way we just went through it of setting a cell and sort of setting the different cells individually, right? But you can also use JavaScript to set the cells. So here, maybe I set ARGB, maybe I set a particular cell, maybe I make it noisy. How did it know to do that? Well, I coded it using JavaScript. So this is a little above and beyond. I don't know anybody's level of skill with coding, but for me, this often makes sense to say any function I name here. So for instance, the noisy one. Here's my function noisy that I wrote. I use some for loops to loop through the matrix, and I use the math random object to generate a random number. So every time I hit noisy, it'll be a different random number. And you could go through and see how it is that if I do red, I can change the whole thing red. And how did I accomplish just to set a cell? So another way to fill a matrix is with JavaScript. If you're into coding, that may be a pretty powerful option for you. Although the timing of JavaScript is not as good as it could be. Another way to fill a matrix is with the jit.gen object. This is complicated, but the fastest way to do things. It looks pretty terrible, but it also has a way to code within it if you like coding. So here again, I do a for loop in a code box. This would take some investigation on your part to learn the jit.gen stuff. But here, what am I doing? I'm setting a cell. So here I can move that cell around. And you see it looks a little feedbacky, so I made a little feedback patch using the JIT operators, so JIT multiply and JIT plus. So here this is written to a matrix, and this matrix is named the same, so it feeds back. I reduce the strength of that matrix with a value and add it back to the original matrix. And that's why we get a little bit of trailing stuff there. So if you choose examine, you can see my noise here is also another code box. Pretty brief amount of code if you choose to look at that. And here's one that does not use code but uses the gen as a patching environment. Little tougher to get at individual cells for me. But this one looks like this, right? Sort of this idea. And you can see how I did that if you choose. None of this is required, but I think for some of you who know how to code, the JavaScript option is really good, and then the gen option, if you use the code box, is going to make your life a little better. And then finally, another way to fill a matrix is with a jit.fill. And jit.fill names a particular matrix called fill me, so here's fill me here. And here we have the R plane, so I make a multi-slider list, and here we can see my window being filled up. So I fill it with, that's interesting looking. So here you can see the P window actually interpolates to answer some of Tyler's question. There's actually interpolation built into some of these to the matrices. And then I could add for each cell a little bit of red. Yeah, like this. And then change the green on a couple of them. And more blue. Maybe this is an intuitive way for you to work. And I could turn on the interpolation and make it look like that, which looks pretty good. So interpolate this window too. So now, because this window is bigger than 4 by 4, right? It's actually 320 pixels. It interpolates so that now we move smoothly between those pixels. So this 4 by 4 gets interpolated across a bigger area. So we actually color more pixels than we specified through the interpolation. So I'll leave this patch up on the Folio site. Again, it's not, some of this is pretty advanced. So it's something if you choose, if this rings a bell for you, then do it. If it does not ring a bell for you, then maybe just take a glance at this bottom part, because this is pretty useful. And this other stuff is harder.
Is it at this point, it's probably just better to use Gen instead of JS, because it's like the way they're going to go in the future, right?
It's a lot faster. So using Gen, I mean, what this basically does is it makes a max external. You know, that's what it really is. It's compiling down to a max external. It's as fast as C. Whereas JavaScript is just not very fast. But for me, I code it faster. So I guess if I were doing ideas, right, I might say like, oh, I think I will just do it in JavaScript. I'll code it there, and then I'll figure out how to do it in Gen. That would kind of be my thing, because this code box is pretty good, but we've got some esoteric things like what is cell, what is dim.
But if
there's
you
not that many.
If you use Gen a lot, you know what those are probably.
Yeah, or just download the document that says what all the objects are. There's not that many objects. It can be a little tricky. You know, for me to be able to move this cell around was harder than I thought it would be. It's not a lot of code though, right? That's all the code. But it was tricky. I like the code box better than this patching environment, which also, you know, has its own code. But I'm a fan of for loops and if statements. I like things like that. But if you like patching, this can work too. Very powerful, but pretty advanced. And I don't know if we have time to really go all into it without totally confusing half of the class and maybe not doing what we want to do. All right, so the homework is up on Folio. Let me see if I can get there quickly. Probably not. Here we are. Today is Thursday. What? Okay. And here's the homework. You are to study these 2 tutorials by next week on Thursday and complete the assignment for this week, which is to make a short recording, a short abstract film using matrix manipulation. Feel free to explore creatively. Exactly what I said. And you'll turn that into this Dropbox. Just drop in the movie there. And again, don't try to eat up all of your time doing this. Spend as much time as is necessary to make it. And if you're super interested, you can go further. But again, my assessment of this is: are you able to deal with these matrices in some way, and are you able to make the recording? That's all I'm very concerned about. Any questions before we dismiss?
I have a question. What resolution should we aim to do the video in order for it to be feasible through Folio and all that?
I would do 1920 by 1080. I like 1080 video. Why not? I mean, it's going to be a bigger video, so it's up to you.
Do you think it's going to be easy to send through Folio even if it's a bigger file?
If it's too big, if there's some problem uploading the file to Folio, just upload it to Google Drive and give me a link. We'll just work through it. I'm not sure the file limits on Folio.
Okay.
Although, you know, yeah, I'm not sure the file limits on Folio. I guess we'll find out this semester. We'll make big files with movies. All right, anything else? Questions, comments?
Nope.
You may have already answered this. Just a second, but are we gonna have like last semester where there's like a assignment due every class, or are you thinking we're gonna do it like once a week?
I'm trying to do once a week. I'm trying to make the assignments a little less stringent.
Okay.
I'm trying to spend less time on them. So some of the criticisms from last semester were that people didn't have enough time to explore freely. So this particular assignment is addressing that complaint. And I'm trying to make the assignments such that they don't take a lot of your time. The downside of that is actually you do have to spend a pretty good amount of time doing this to get good at it. But I will just tell you that that's the case, rather than burdening you with a lot of assignments. I think several of you are going through trying to get your final projects done for your master's degree. I recognize that. And so I'm trying to lift the burden a little bit here. At the same time, if this is an area of interest to you, then I do recommend spending a good amount of time on it. And that's really the only way to figure it out, is time and effort.
Cool. I was just checking.
Yeah, trying. My goal is to reduce your petty workload. So like just assignments that you do that never go anywhere, and also to reduce my workload of having to grade a whole bunch of petty assignments, which was really hard last semester. So this assignment, like I said, is due next Thursday. That was another criticism, is we need to make these, give us 1 week to do it. So there's 1 week to accomplish this task. And then we have the flip side of the Tuesdays, which is more aesthetic or historical. And I'm trying to do that in such a way where you should have a general concept. I don't want to give a bunch of quizzes. I'd rather just maybe at the midterm for you to be able to talk about it in some sort of larger scope. All right, any other questions, comments, jokes?
Chickens.mp4.
What?
Chickens.mp4.
Oh, that is a good joke.
Yeah.
That's a good one.
Yeah.
Did you hear about the police station that got their toilet stolen?
No.
They couldn't find the culprit because they had nothing to go on.
All right, there you go. And with that, I will end the sharing. I'll end the recording.